there you are, back again for free response question number 6. Back again, that is, if you've been following us down this path of the 2016 Practice AP Calculus AB exam. If you were here for the previous videos, welcome back. If you are here for the first time, welcome. Okay, we are just going to cover, as I stated, free response question 6, which is the last question for this examination. All right, no calculator is allowed. Two things very quickly. I always start with this. Number one, follow me on YouTube, because that's the only way you're going to get notifications when I put up new videos. Yes, this is the end of the test here, but I will be doing more AP Calculus exams, and you want those notifications? All right, you got to follow me. That helps you, okay? Like the video, because that helps me, all right? While you're down there ringing that bell and liking this video, go down there and in the comments if there's an exam you want to see, maybe the 2003. I don't know. Put it down there, and maybe I'll do one of those in the very, very near future. And without any further time wasted, let's begin the end to this test right now. Number 6 states, let f be the function defined above. They give us this piecewise function here. When x is less than or equal to 1, we got 10 minus 2x minus x squared. And for any x value greater than 1, we have 3 plus 4e raised to the x minus 1. So 6a is asking, is f continuous at x equals 1? Why or why not? Love it. Let's get started here. Start with the little blue. So first of all, in order to figure out if something's continuous, the limit as x approaches 1, because that's what they're asking, of my function needs to equal f of 1, the actual coordinate, okay, the location of the actual coordinate. All right? So I guess, I don't know, let's start with this one here. In order to find the limit as x approaches 1 from the left side of f of x has to equal the limit as x approaches 1 from the right side of f of x. All right, so let's go ahead and see if that is true first. Let's find the actual limit as x approaches 1. And we're going to follow that function from the left side and the right side. The left side is any time my x value is less than 1. Okay, that's the left side. So I'm going to use this function right here. And of course, the easiest way to solve limits, if we can, is to just plug in. So I've got 10 minus 2x minus x squared at a point where x is 1. So I got 10 minus 2 times 1 minus 1 squared, which is 10 minus 2 minus 1, which is 7. Okay, this function approaches a value of 7 as I approach 1 from the left side. Let's check 1 from the right side. Anytime x is greater than 1, that would mean we're coming from the right. So we're going to use this function, 3 plus 4e to the x minus 1. We're going to use that as we approach from the right. So 3 plus 4e to the x minus 1. Let's throw that 1 in for our x. 3 plus 4e to the 1 minus 1. Woo! E to the 0. Anything to the 0 power is just 1. 3 plus 4 is 7. Great. This is good. 7 equals 7. That's good, which means this has a value of 7. Does it equal f of 1? Well, now we're just plugging in x equals 1 into our function. Which one, the left or right, will I pick if x is 1? This one right here, because it's less than or equal to 1. So I've got to use this. We already did that. We did that right here. Look at the bottom left of your screen here. We already plugged that in. So I'm just going to say f of 1 is 7. We already showed the work. If these two are equal, which they are, that means it's continuous. So we've answered the question with our work and everything, but let's actually answer it like this is an exam we're taking. First question is f continuous? Yes, f of x is continuous at x equals 1. I'm going to be specific, okay, because they asked me at x equals 1. Okay, now why or why not? Since the limit as x approaches 1 of f of x is equal to f of 1, which is 7. Okay, that is a fantastic response for this question. The work is done. It is all shown. You need to start with that blue ink right in the center. For continuity, the limit has to equal the coordinate. So the limit as x goes to 1 has to equal f of 1. Very good, very good. 6b, find the absolute minimum. That means the lowest of low, not just the local minimums, the absolute minimum value, and the absolute maximum value. Okay, that's the highest of high. All right, not just all the mountaintops in your graph, but the highest point. Okay, the value of f on the closed interval from -2 to 2 inclusive. This is very important when we have a graph that has a closed interval. I'll explain why in a moment, especially when we're looking for mins and maxes. Show the analysis or work that leads to your conclusion. Great. All right. In order to find absolute mins and maxes, those can only occur at critical points. That's where your first derivative is equal to 0 or undefined. Okay? However, notice I said endpoints are crucial. Okay? If I have a graph that goes down, comes up, and goes like this. Okay? Let's say this is a graph. This is not the graph of our piecewise function. I'm just giving you an example. This is a max. This is a min. It's obvious. But what happens, okay, what happens if there are endpoints here? Okay, I'm going to lower this one right here. What happens if we have endpoints here and here? Well, this is still the max because it's higher than this point, but this becomes the absolute min because it's lower than this minimum right here. So we need to check those endpoints. Do not forget to check the endpoints, all right? And when I'm looking for mins and maxes, I want to find the y values, the x value. If I have a min or max, a coordinate, the x value is where it occurs. The y value is the actual value of the min or maximum, okay? So let's start here. And first, let's rewrite what our piecewise function was. We had f of x equals 10 minus 2x minus x squared. That's when x was less than or equal to 1. And then we got 3 plus 4 to the e x minus 1. That's when x was greater than 1. Okay, this is what we got here. So I got to take the derivative of this. So I'm going to do this kind of individually because we have two pieces. Let's see where this is equal to 0 or undefined. All right? All right, the derivative of that. Okay, so the derivative of 10 minus 2x minus x squared is -2 minus 2x. Where does that equal? That will never be undefined. There's no value of x that makes that undefined. So let's add 2x to both sides. I got -2, bye-bye, equals 2x. Divide by 2, -1 equals x. This is where the first derivative is equal to 0. It's a possible critical point. Our mins and maxes. Our slope might change there. Okay? Now, let's do the derivative of this one from the right side. So the derivative of 3 plus 4e to the x minus 1. Okay, the derivative of any constant is 0. For the derivative of e to the x minus 1 is e to the x minus 1. All right? Where does this equal 0 or undefined? If you know your rules of exponents, first of all, this can never be undefined. Never. Never! But can it equal 0? No. This will never be 0. How come? I would have to say 4 times 0. Okay? E to the x, or e to the x minus 1, will never equal 0. If the exponent is 0, that means e to the 0 will be 1. We just did that. Okay? If the exponent is negative, that's fine. We just flip it and put it in the denominator, and it would still not be 0 or undefined. So this will never be 0 or undefined. So there's no critical points for the right side. But we need to check right at 1. We said it was continuous at 1 in the previous problem, 6a. Okay, we check to the left of 1. We check to the right of 1, but what about right at 1? Okay, well, let's put 1 into each one of the derivatives and see what's going to happen. Okay? Let's find out what's going to happen, because derivatives are a lot like limits, I should say. They need to be the same from both sides. Okay? Otherwise, you have a corner. For example, if I have a slope of -3 here, and then I have a slope of +1 here, right here's a corner. If those slopes aren't the same, I'm going to have a corner. All right? And as we know, a corner is undefined slope, which means it can be a critical point. So, this is right at x equals 1. Okay, here's my derivative from the left. So we got -2 minus 2 times 1. All right? That would be -2 minus 2, which would equal -4. That's my slope from the left. The slope from the right, okay, I'm going to take this right here. 4 to the e 1 minus 1. All right? Which means that's 4e to the 0, which is just 4 times 1. Okay, that's a +4. Since these are not the same, okay, I got a -4 going to a +4. That's a corner. Okay, the derivative, okay, at x equals 1 is a critical point. How come? Because it's a corner. Even though corners are continuous, I mean, we just found out in part A it's continuous, but that doesn't mean it's a straight line. Those two graphs come into that x equals 1 at different angles. All right? So we have, and here's where we highlight, highlighter. At x equals -1 is a critical point, and x equals 1 is a critical point. Okay? So we're going to do a little number line here. We're going to do a little number line here. Ready? Okay, let's do a little number line here. Okay, this is how I like to actually visually see my mins and maxes. All right, here's my value of x. Here's the endpoint, -2. Here's the endpoint, +2. We have two critical values, at -1 and at +1. So we are going to check our derivative at some spots in between there. Green. 0. First of all, when I'm checking 0, I'm going to use the left side, okay? The left side. The derivative of the left side was this right here, okay? So I'm going to put a 0, okay, -2, -2 minus 2 times 0 is -2 minus 0, which is -2. That's negative. So this slope is going downward. All right? Let's now pick, we'll do these in different colors to color coordinate, -1.5. That's still the left side. I'm still going to use this because it's still smaller than 1. So -2 minus 2 times 1.5, which is -2 minus, -1.5. Okay, that's +3. That's a positive value. So it's going up the slope. So this might be a possible max. I'm not sure. I'm going to have to check that. All right? Now let's pick, oh my goodness gracious, this color. Let's check a positive 1.5. I'm going to use this one, okay, because that's bigger than 1. So I'm going to take the derivative. When I say use that one, I'm taking the derivative of this side, which is 4e to the x minus 1, which is 4 times 1.5 minus 1, which is 4 to the 1/2, which is a square root of 4, which is 2. It's positive. So it's going up. So this might be a minimum. So what I'm going to do, when everything's all said and done, I'm going to check an x value of -1 to figure out my y is. I'm going to check an x value at 1, okay? And then I also got to check the endpoints at 2 and -2. We got a lot of work to do here. I need some more space here. This definitely is a 6-point question here, or a number 6 question. So here's my x's. Here's my y's. We're going to check the endpoints, and then our possible max and our possible min. All right? Anything less than 1, anything where it's actually less than or equal to 1, I've got to go back to the original. Okay, if it's less than or equal to 1. Okay? So for these three, I'm going to use 10 minus 2x minus x squared. For this one, I would use 3 plus 4e to the, oh my goodness, x minus 1. Yeah? 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 That should be a positive too, by the way. All right. So here we go. I'm going to do mental math quick. If I throw a -2 in here, that gives me 10. -2 times -2 is plus 4 minus -2 squared, which is still 4. These cancel, and I just end up with 10. Let's throw a -1 in. So it's 10. -2 times -1 is positive 2, minus a 1 squared, which is -1. It's -1. Okay, I'll be okay. It's 12 minus 1. Is that 11? It's 11. All right, it's good. All right, so that looks like it might be a maximum so far. But according to our graph, okay, it looks like this might be a maximum, but we got to check this to see if it's higher. All right, and then this so far at 10 is a minimum. We got to check this to see if it's lower at 1. All right, so let's put a 1 in. Let's put a 1 in. We're going to do this one. 10 minus 2 times 1 is just -2. Minus 1 squared, which is 1. Well, that's 10 minus 3. That's 7. Okay, this looks like it's lower so far, okay, than this. Ooh, and now I'm going to throw a 2 into here. And we're not going to be able to come up with an exact value without a calculator, but you know what? Who cares? I got 3 plus 4e to the 2 minus 1, because I threw an x, a value of 2 in there, which is 3 plus 4e. Okay, e is 2.718. Okay, 2.718. All right, which means, let's say I made this a 2. Let's round down. 4 times 2 is 8, plus 3, that would be 11. But it's 2.718. It's closer to 3. 4 times 3 is 12. 12 plus 3 is 15. So this right here, I don't know what it is without the calculator, but I know it's in between. If I made e a 2, that would be 11. And if I made e a 3, it would be 15. And it is e is closer to this number. So that is bigger than this right here. Okay? This is my maximum. This is my minimum. Okay? So let's see if we actually answer the question. That was a lot of work. Show the analysis, which we did to lead your conclusion. Find the absolute min and maxes. Let's write it. There's a min of 7 at x equals 1, and a max, I guess we should say absolute, because this is what they're asking us. Absolute max of 3 plus 4e at x equals 2. So one of those endpoints did end up being our absolute, in this case, maximum. That was a lot of work. It was a lot of work, it was a lot of thought. You know, sometimes I catch myself going fast and I got to slow down because I make mistakes too. In previous videos, I've made mistakes. Even here, I wrote that as a negative first. I had to make that a positive. And there'll be areas where, you know, and I think right here, at first I didn't put the negative in here. I had to just toss that in there. When you go fast, that's when you make mistakes. I got to try and pull myself back. But that's 6B. Woo! That was a lot. And speaking of a lot, we have 6C. Find the value of the integration from 0 to 2 of f of x. Okay. Well, again, let's write down our piecewise function, 10 minus 2x minus x squared if x is less than or equal to 1, and 3 plus 4e to the x minus 1 if x is greater than 1. All right. All right, here we go. So if we're going to integrate this whole thing from 0 to 2, well, it's going to be split right at 1. Okay? So the top one is going to be from 1 to 2. This bottom one is going to be from 0 to 1. That will cover all from 0 to 2. Okay, we're going to have to split that up, which is fine. Which is fine. Actually, see, again about going fast, this one on the top, since it's less than 1, will be 0 to 1. And this will be 1 to 2. Again, going fast. See, good thing, man, I'm catching these. It would stink if I did all that work and I didn't catch those till the end. So, we're going to integrate from 0 to 1. That is from 0 to 1. 10 minus 2x minus x squared. Don't forget the dummy variable. And I'm going to combine that with the integration from 1 to 2 of this one. 3 plus 4e to the x minus 1 dx. All right. Okay, this is going to be a lot of simple algebra. So again, let's not go fast like Mr. Visca did right here a second ago and make a boo-boo, especially if we don't catch it. 10x minus x squared minus x cubed over 3. That's the integration of this right here. I want that from 0 to 1. And gosh, I love throwing zeros in. Plus, this is 3x. And this is just 4e to the x minus 1. I want that from 1 to 2. All right? What are you going to do? All right. Good, 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 good. Good. All right. Let's work with the left side here. I hate how that board does this to me, but I got 10. I'm going to put in the upper bound first. Minus 1 squared minus 1 cubed over 3. This whole thing minus throwing in zeros. Oh. I mean, if I throw a 0 into all these, it's going to be 0. So I'm just going to put one big 0. Save me some time and space. All right? Now let's throw in the 1 and 2 on the right integration. 3, the upper bound is 2 first, plus 4e to the 2 minus 1, minus, I should have done this. This is separate. And I'm going to add it to whatever this is. All right? Let's throw in the 1. Okay, 3 times 1 plus 4e to the 1 minus 1. Okay, I feel like we've done a lot of this work already, but you know what? It's cool. It's all right. 10 minus 1 minus 1/3. Okay, which is going to be 9 minus a third. Oops, third, which is 8 and 2/3. And if I wanted to do that, I could say that's also 24, 25, 26 over 3. All right. Plus, okay. All right, it's going to be 6 plus 4 e to the 2 minus 1. That's it, just 4e. Okay, I got to distribute this. Minus 3. This is 0, which means e to the 0 is just 1. Minus 4. Does that look right? Yeah, it does. So we have 6 plus 4e minus 7. 6 minus 7 is a negative 1 plus 4e. All right, well, we have this right here. Let's just combine all this poo-poo. 26 over 3 minus 1. I'm going to write 1 as 3 over 3 so I can combine those. Plus 4e. When I combine these, I get 23 over 3 plus 4e. And that's all we can do. That wasn't so bad. That was not so bad. I like it. I like it a lot. All right, we're done. 23 over 3 plus 4e. If you're not comfortable integrating, yeah, this is going to be bad. All right, so first and foremost, you need to understand that since this splits at 1, your integration needs to be split also at 1, right in between there. Okay, that's the big thing to take away from here. Beyond that, it's just simple integration. This is simple integration, simple algebra. Calculus is so algebra heavy, it's crazy. We are done. We are done with free response question 6. Thanks for coming along this ride with me. I really enjoy having people. I like seeing people when they watch these things. I'll put them up and a week later, 30 people watch them. That tells me that somewhere, some calculus teacher is assigning some of these problems from old tests, and some of you guys are watching them. And you know what? That's great. If it helps you get them done and helps you understand them, that's fantastic. Like the video, that helps me. Follow me. That helps you. And if you look in the bottom right-hand corner, I don't know if that's fuzzy or not on your screen, underneath my recording little window, it is 8:37 a.m. It is Halloween. It is October 31st, 2022. Get tons of candy. I hope you're going to a party. Stay safe. Celebrate with friends. Have a good time, because life is more important than calculus, but not that much more important than calculus. I'm kidding. I'm joking. Have a good time tonight. Stay safe, and I will see you later.